Pangeo is a cloud deployment of X-ray and Jupyter Hub that helps atmospheric scientists and oceanographic scientists analyze large data sets on the cloud. It's currently public access. You can sign in with your GitHub credentials. So we're logging now into a Jupyter Lab session. Jupyter Lab is like Jupyter Notebook, but has a few extra features like terminals and file browsers, which we'll find useful when working on a remote environment. This is running on the cloud on Google Container Engine, and we'll use that to both launch our own personal notebook server and also launch many Dask workers when the time comes. This takes a minute or two to start up sometimes, so I'm going to pause the recording. After my container starts, I'm taken to a Jupyter Lab session. Jupyter Lab contains the standard Jupyter Notebook, but also things like a file browser, where I can look at my various files and navigate my user space. I also have options like terminals. So I can look around in a standard Unix environment and again manage my environment, maybe pip install some software or conda install some software, and generally speaking work with my data. However, today we're mostly going to look at using a notebook. So this notebook is going to use X-array and Dask array to analyze a much larger data set on sea surface altitude, and we'll track sea level rise over time. We'll import some libraries and open up a data set. This data set is stored in the ZAR format on Google Cloud Storage. This is going to be, I think, maybe a few hundred gigabytes. It's not very large, but certainly larger than we want to put on our cluster, on our laptop. This data set has a variety of different variables. We're mostly going to focus on the sea level altitude, which is sizable. It's a few thousand by around 1,000 by around 1,000, broken into chunks along the first dimension, the time dimension. Now, in order to do that processing, we're going to need more workers than what we have here in our notebook. So we're going to connect to Kubernetes, where everything is running, and ask for more Dask workers. So Dask is going to help us scale out our processing. We'll ask for 40. This might take a little bit of time depending on how busy the cluster is, but it looks like they showed up pretty quickly. So let's go ahead and look at a little bit of our data just to see what we're looking at. We'll use the X-array API to look at the data for the year 1982, a particular day in August. So what we're seeing here is the altitude of the oceans on this particular day and this particular time. Red is higher, blue is lower. You see relatively calm waters around the equator with some interesting high variability regions, around various capes or across Japan, anywhere where there's maybe some wind activity coming off of a coast. So this is one particular slice of our data. We might want to look at our data set over time, look at the entire thing, and do some analyses. So this data set is around 70 gigabytes in memory. It's not huge, but again, largely we want to look at with our laptops. So we're going to do some computations here. We're going to compute the average of all the spatial dimensions, average across just one of the spatial dimensions to look at how things change over latitude, compute the variance over time. Now to do this, we can run this, it'll be fine, but let's first open up the Dask dashboard to get a sense of how things are going. When we started our cluster, we had this link up here at the top. We're going to click that. That'll take us to some information about our 40 machines we've asked for. So I'll put my notebook and my dashboard side by side. I'm going to scroll down to where we were before. Let's go ahead and ask Dask and X-array to compute these things for us. So these computations we've specified at a very high level, but in order to actually execute them, we're going to break them up into many small pieces. That's what you're seeing here on the right. So X-array is using Dask array to break up these computations into many, many small tasks, each of which can easily fit inside of a single computer. You're seeing here in the center the activity of each of our 80 cores and what they're doing over time. They might be computing moments like means or standard deviations. They might be communicating amongst each other, that's the red, or they might be loading data from the cloud store. Up at the top, you're seeing the memory use across our cluster, or the active tasks running on each core. Now that that's finished, we can go ahead and look at some of our results. I'm going to go back to full screen on the left so we can get some bigger pictures. So here we're going to look at averaging over all the spatial dimensions and just looking at the sea level altitude over time. So we see a couple of obvious features. We see the cyclic dependencies with the seasons. We also see an increased rise over time. This is the sea level is rising, and we can see that very clearly, very unambiguously here by looking at the data. We look at some other plots. Here we've averaged over the longitude and we've kept the time and latitude axes fixed. This allows us to plot and see how the sea level altitude has changed over time, but also on different latitudes. So we can see maybe how the north compares to the south, or how maybe there might be some fine structure on certain latitudes, like here around 38 north. There's some particularly high altitudes here. We might also look at the sea level variability. Here we've taken the standard deviation across time, so we can get a nice plot here that shows not the height or the shallowness, but how much that varies over time. And you can see again that areas just to the east of coasts tend to be particularly variable. You might find that the tides shift more frequently or heavier on the east coast of your continent rather than on the west coast, where waters might be a little more calm or Pacific. So that's it. We've seen analyzing large data sets with X-ray and DASC on the cloud, and this allows us and many other scientists to easily analyze their data, even if they don't have a cluster of their own. They can go to pangeo.pydata.org. We'll try to keep this up as long as possible. But yeah, please come and check it out.